looked into the concept of how can we get the image captured on the particular, it can be of eye or it can be of any viewer, right? So in this particular image, as you can see, there are multiple things which are present, right? And one more thing which you need to know is this is a synthetic camera model. So what do you mean by synthetic camera model? Synthetic camera model is nothing but one second, Aditya.
Okay, sir. ಸರ್ ಹಲೋ ಸರ್ ಸರ್ ಆಡಿಯೋ ಮ್ಯೂಟ್ ಆಗಿದೆ ಹಲೋ
Can you hear me now?
Yes, sir.
Okay.
It was
Sorry.
muted right after that. This one camera model only. As soon as you went for a minute now, that time only it was muted.
Okay. Fine. I'll just brief it out again. No problem.
Oh, okay, sir. Oh, okay, sir.
Okay. Okay. So this is the something called a synthetic camera model. We have the object over here, and the object is in the plane P. The P is nothing but it's a point P where the object is standing. So we have an image plane where the image, whatever I can see, will be falling on the plane. As we get this plane nearer to the camera, it shrinks, right? Meaning that image has to be sent towards the lens, and that particular image, when it falls on the back of the camera, it will be reverted. Always in the synthetic camera model, the image will be reversed. And we have a projection which you can see here. The object's view is the front view, right? The camera is standing in front of the object, so we can see only the front view. So the projection of P is what you can see from the camera towards the P. This is called as projection of P. And where all these lines, array of lines, will meet is called as center of projection. So the center of projection will be in the lens, right? So this is the very old technology, which is around 200, 250 old camera, right? This is how the image was actually formed on the camera without any digital means. It was analogous, where we used to put one particular negative over here in the camera, and we just open it or expose the light to that particular photographic plate for few seconds, so that the complete image will fall on the photographic plates and it gets exposed. That is something called as exposure. So we have the projector, the lines which you can see is called as a projector, right? Many technical terms are involved over here. So anyhow, the first factor is the light. The local lighting is very important. The light will be falling on the particular object, and the light rays will be getting back towards the camera. So projects geometry onto the image plane. We use the information of the shade point also. So the shade point also gives many information about the image, right? So by having this common knowledge, we look into the next topic, something called as pinhole camera. So pinhole camera is very simple. It is using pretty terms, right? So some technical terms. This is a cardboard box, right? In the old, it was a cardboard box which is covered on all the six sides, and we have a very small pin hole which is in the size of a safety pin, right? So where only one ray of light could pass through this particular point. Okay, so in this is actually a pinhole camera where we have some coordinates of the object which is having xyz, because it's a three-dimension space, right? So we have xyz. This particular point should be formed on back of the cardboard box, right? So we have the center over here. The center axis is nothing but, here we have taken it as z axis, and this is the y axis, and perpendicular to z axis and y axis we have the x axis. Okay, so this goes the x axis. On the top we have the y axis, on the right we have the z axis. This particular point is present in the open space at the coordinates xyz, right? So this particular point has to be captured on the back of the camera, meaning all the rays here will meet at one particular point called a center of projection, and it falls on back of the cardboard box, right? Now the image will be reverted, and it falls on the cardboard at the coordinates xp, yp, and zp. By using some trigonometry functions and concepts, we find the projection at the point of XYZ. What is the projection at this particular point? XYZ. In order to do that, we have to calculate what is XP, YP, and ZP. So XP can be calculated as we are going towards the negative time, negative side. So X will become minus X. So minus X divided by the Z by D. D is nothing but the distance between the lens and the back of the cardboard, right? So that is something called as the distance. So that is the value of XP. What about YP? YP is also negative. As you can see, I'm going towards the negative, that is down with respect to the y-axis. So YP is equals to minus Y of Z comma Z by D, right? And anyhow, we have the Z here, and the Z is nothing but as we are also going towards the negative Z, but the negative Z or the Z is nothing but D itself. D is the distance between the lens and the back of the cupboard. So these are the very simple equations which you have to look into. So next, coming into the advantages of having the local lighting is separation of objects, viewer, and light sources. As you can see, the light sources is different. Here we can see the light sources is different, the object is different, and the viewer is different. We can identify, right? So local lighting will help us in separation of object, viewer, and the sources. Two-dimensional graphics is a special case of three-dimensional graphics. Yes, this is important terms. Our laptop or whatever the image which we actually generate, we see it in two-dimension screen. Our laptop is a two-dimension screen, right? So we have only one plane, and we can move the cursor in the x-axis and the y-axis, right? So we are generating an image that is of 3 dimension, and we are showing it in the 2 dimension, right? So which leads to the simple, we need a applications program interface, a software in order to do this. So what are the major things which a software has to deal with? It has to deal with what type of objects we are using. It has to deal with what type of light I'm using. Am I using a distant light or a bulb or a light source or from a candle or from a light from my infinite source? It all depends. What type of camera are we using? Where is the camera? Which side it is, right? And other attributes. So we need to have some software or set of programs which are dealing with these particular attributes. The implementation will look into it. So this particular implementation has to be implemented on a very fast hardware, which actually helps us in order to gather the information. So allows, we need to have multiple process dealing with it, something to deal with the pipeline and parallel computations. So what do you mean by pipeline? Pipeline is nothing but in order to generate an image, the data has to move through multiple blocks in order to generate its points, right? So it has to go after one block to another block, right? So the input of one block will be output from the another block. That's what is important when it comes to the pipeline. And parallel computations refers to, I need to be doing this particular generation of points so fast that all my points, every pixel will have its information over here. Every pixel has its own information that we need to understand. So next is pen plotter model. This is a very old technology where I have a particular plane and I have two sticks which can move in x direction and the other one is on the y direction, right? So we can describe such a graphic system with two drawing functions, one with move to and line to. Move to is nothing but I'm moving just my pen from left to right or top to bottom, right? And the other one is line to refers to when you make your pen start writing, right? Moving from x comma y value to the next x dash comma y dash. A small example here which you can see is move 0 comma 0 line to 1, 0, line 1, 1, line to 0, 1, and line to 0, 0. So in other words, this is actually telling us the information about draw a particular value from in the form of a square, right? Move from 0, 0. 0 means this first value is x. That means on the right, right? If I say this particular value, if I take this particular point as 0, 0, the first thing is 1, 0, 1, 1, 0, 1, and 0, 0. So it is like I am drawing a square, right? So this can be done with respect to the drawing of square. Next comes another example, move to 0, 1. And yeah, basically this is a small way how we move the pen from one place to another place. So we have, the another thing is we are dealing with three-dimensional application program interface. See, yesterday we saw about the color cube. The color cube is in 3 dimensions. We have to represent it in a 2-dimension plane. How do we do it? So we need some application program interface to deal with 3 dimensions. That has to be dealt with objects, viewer, light source, and material properties. So when we look into the specifications of any camera, we have 6 directions of freedom, right? So we look into it. What are the 6 dimensions of freedom? One is, if I have a point over here, the positive x, the negative x, the positive y, the negative y, the positive z, as well as the negative z, right? So there are 6 different degrees of freedom, right? We also have to look into what type of lens we are using, what type of film size we are using. And the important thing is, how are we capturing the image when it comes to the orientation, right? We can also move the camera in, we can twist it. We can twist the camera in x-axis, in the y-axis, as well as in the z-axis. So the specifications goes in this way. These are the types of specifications. So just go through once. So position refers to the camera location where the camera is. The camera usually is given by the position of center of the lens, which is called as COP, that is the center of projection. Orientation refers to, once we have positioned the camera, we can place a camera coordinate system with its origin at the center of the projector, meaning I can move my camera towards or away from the object. The focal length determines the size of image, whether you want a bigger image. In other words, you can zoom it and unzoom it. That's what it says. Film plane is the back of the camera has the height and the width. So yes. Next comes the architecture and model. So earlier graphics system, main intensity. You have seen the older television sets, right? Where our things is nothing but the value of the digital information, whatever we get, has to be put into the TV, which is analogous, right? That's why I'm telling you about the older television set, right? Some digital information which is coming from the some device, I have to convert that digital information to analog, meaning whatever the bits, that is zeros and ones, which I am getting, has to be converted into analog. That is in the form of waves. That has to be pushed towards the screen, and the TV will be able to analyze this analogous information, and it can print it on the screens. That was the early graphics system. Nowadays, we have something called as digital processor, which will take care of the digital input, right? Nowadays, we all have our set-top box. The set-top box is the digital device. The set-top box is having its own display processor, right? It gets the information from the host, that is from the, probably if you are using Airtel or Tata Sky. So the host is nothing but those are the companies, right? Airtel and Tata Sky. They are sending the information in the form of a digital signals, and this digital signals will be processed. Meaning today we have high speed devices or the televisions which can have which has the capability of printing it on the particular television set, right? So it has to be done so fast that we need a dedicated display processor to do that. So this display processor has to know what exactly I'm getting next. So it maintains a list, something called as display list. What is the information which I need to print in the next immediate millisecond, microseconds? Yes. So how the approaches goes? Approach is quite simple. It has to initially starts with the vertices, right? And the important thing is all our television sets are digital. So they are filled with pixels. Pixel refers to picture cells, right? So we have the vertices. It will be sent towards the vertex processor. In the vertex processor, it will identify which particular point should be present in which particular place. Next, if the particular point is falling outside the particular plane, it has to be clipped, meaning it has to be taken off. And the primitive assembler takes place. Next comes the rasterizer. The rasterizer is nothing but which converts the digital information into picture cells, right? So next comes the fragment processor, where which part of the image should come at which particular place deals with the processor, and we have the pictures. As you can see, this is the application program on the left side, and on the right side, we have the display. All steps can be completed in hardware on the graphics card. So the graphics card does these many things. What are the things which it does? Vertex processing, clipping and primitive assembly, rasterization, and fragment processing. Right? Initially, the input is the vertices, and the output is the pixels. I hope you understood. So
Yes,
next
sir.
comes, yeah, next comes what is the first part or first block? That is our vertex processing. Much of our work in the pipeline is converting the object representation from one coordinate system to another coordinate system, the object coordinates, the camera, and the screen coordinates. Each change of coordinates is equivalent to matrix transformation. Vertex processor also computes the vertex colors, right? So we have some information on these, yeah, which are um, where I'll give you the particular this thing, a document ಕಳಿಸ್ತೀನಲ್ಲ study material ಅದರಲ್ಲಿ ಇರುತ್ತೆ. We can easily go through it, right? So you understood. So a vertex processor, clipper, rasterizer, and fragment processing. This is actually the information or the pipeline. This is a pipeline. One input, one output is an input to another stage. So next comes the planar, the projection into the planes. Consider the line AB. We have the AB over here. This is the plane, right? This is the center of projection. I want this particular line to be printed on this particular plane, right? So considering the line AB, the perspective projection is a single viewing location, and parallel is nothing but straight. See, projection means two things. Whether I want the particular object's information to be falling at one particular point, or parallel projection means it just moves on. The center of projection is not at one particular point, it is at the infinite. Okay. So don't break your head at this. This is not needed much. And yeah, we need the concept of clipping. What do we mean by clipping actually? The clipping is nothing but, see, in my laptop, my viewing area is this much only. Anything goes outside the particular screen, that information has to be cut off, right? So that is called as clipping. See, I'll just do one thing. I'll just, uh, can you see the browser now?
Yes, sir.
You can see this V2, right?
Yes, sir. Yes, sir. It's visible.
What I'll do is I'll just take this particular browser and push it towards the left. V2 ಇವಾಗ ಮಾಯ ಆಯ್ತು ತಾನೆ?
ಹೌದು ಸರ್.
This is called as clipping. My computer is doing the clipping. It only shows which has to be inside the particular plane. Badwadana, it will just delete it off. So that is called as clipping. So just as a real camera cannot see the whole world, the virtual camera can only see part of the world or object space. The objects that are not within this volume are said to be clipped off of the screen. So ಎಲ್ಲ images ಬೇಕು ಅಂದ್ರೆ we have to take this particular viewer at a very long space, right? So if you want to get only that particular object, you have to move towards the object, right? So there will be something called as angle of view. So if you go back, the angle of view will increase. If you go towards the object, the angle of view will be decreasing, right? So on the other side, you can see the back of this is the object. This is the object. This is like a trapezium, right? So what you can see, front clipping plane as well as the back clipping plane. As you can see, the front and back clipping plane, the back is a pretty much bigger one, right? The front is a smaller one. Whatever in between these is called as a view volume. Okay, so all the lines of projection from the back clipping plane should pass towards the front clipping plane, and it has to be moving towards the view plane, and it joins at the center of projection. So rasterization is nothing but, I told you, it is conversion of picture cells. If the object is not clipped out, the appropriate pixel in the frame buffer must be assigned with the colors. Rasterizer produces a set of fragments for each object, and fragments are potential pixels which have the location in the frame buffer. The color and the depth attributes can be done. Vertex attributes are interpolated over objects by the rasterizer. Next comes the fragment processor. The fragments are processed in determining the color of the corresponding pixel. A pixel gain information ಕಳಿಸುತ್ತೆ ಅಂದ್ರೆ what will be the color of that particular pixel, because that is very important. Colors can be determined by texture mapping and interpolation of vertex colors. We use the RGB colors. Fragments may be blocked by another fragment closer to the camera. That is something called as hidden surface removal. Okay, so this is an example, few examples. This is a triangle, and this is a Sikorsky gasket. That's how it looks. So I think we have come towards the end of module 1. So by tomorrow, I'll send you the module 1 notes. You can look into it.
Okay, sir.
Okay. Anyhow, the